In this video, let's address a question which many A-level students taking H2 chemistry ask me. And this question is, why are there no hydrogen radicals formed during free radical substitution of alkanes? So let's answer this question in this video. So recall for the free radical substitution of alkanes, it involves 3 steps. The first step is initiation, where the halogen like Cl2 undergo homolytic fission to form free radicals of chlorine. Then you have second step, which is propagation, which forms even more radicals. Okay, so in the step 1 of initiation step, we only form halogen free radicals. Okay, so to explain why hydrogen free radicals are not formed, we should be looking at step 2, which is the propagation step. All right, so now let's take a look at the propagation step. And let's look at this reaction here. All right, so for this reactions, right, do you notice that the homolytic fission of the CH bonds occur and a HCl bond is being formed? So if you are looking at why there are no hydrogen free radicals, then we should be considering this reaction here with another reaction. So what I'll do now is I'll write out this equation here. Okay, and with the chlorine free radicals. Okay, and I'll write it out twice because I want to illustrate why hydrogen free radicals are not formed. All right, so now let's look at this one here. All right, so in the actual reactions, what happens is there are 2 electrons here, right? 2 electrons here in the CH bond. Okay, so what happens is the one of the electron, okay, forms a bond with the electrons from the chlorine free radical. Okay, and I end up having CH3 free radical, which is also called a methyl free radical, plus HCl. So in other words, right, this involves breaking of CH bond and forming of HCl bond. If I want a hydrogen free radical to be formed, what happens is this hydrogen is formed, and well, let me draw it this way. So this C and this Cl will form a bond. Okay, and then you will have hydrogen free radicals, but we know that this does not occur. So why is it so? Okay, so let's take a look at the second reaction. So if the second reaction takes place, right, it will still involve breaking of CH bond. Okay, but now instead of forming HCl bond, you form a CCl bond. So the reason why methyl free radicals is formed instead of hydrogen free radicals, or in other words, right, why the HCl bond is formed in favor of the CCl bond instead of the chloromethane must be because of the formation of bonds. Okay, there must be something different between the forming of HCl versus CCl bond that makes this reaction favored over this one. Okay, that is why we don't have hydrogen free radicals. So, okay, both involves breaking of CH bond, so nothing to talk about because they are the same. So this is the difference, forming of HCl bond versus forming of CCl bond. So let's look at what's the difference in the HCl and the CCl bond in terms of bond energy. So this is the bond energy detail that I have copied from your data booklet. So from here, you notice that the HCl bond is stronger than the CCl bond. Okay, so more energy will be evolved if HCl bond is formed there as compared to if CCl bond is formed. So that means this reaction is favored, okay, because more energy is being released. And as such, we get the alkyl free radicals instead of the hydrogen free radicals being formed in the propagation step of free radical substitution. Okay, so the reason why hydrogen free radicals are not formed during the in the free radical substitution of alkanes is simply because of the bond energy. Okay, it is more favorable for the reaction to form HCl bonds rather than CCl bonds because the HCl bond is stronger and will give up more heat. Okay, therefore the mechanism, okay, favors this reaction. So we form alkyl free radicals, which goes on to attack halogen molecules in the propagation step. All right. Thank you for watching this video, which is proudly presented by learnalevelchemistry.com. Do check out our website at learnalevelchemistry.com for more A-level chemistry resources. Also, please like and subscribe to our channel. It really motivates us. Meanwhile, do check out our other videos. See you!